Can you tell us about your background in STEM and what you do for a living?
Did a bachelor's in electronics and communication engineering, and I always had a passion of seeing things interact with the environment. So I moved from there into field in robotics, because moving from electronics, which on bench I could see things connect and do something logically on bench, but I wanted to see it move in the world. So for pursuing a career in robotics, I moved to Canada, where I studied. I did my master's in engineering again, electrical engineering, and I did a PhD in computer science. This also gave me a bit of experience in hardware as well as software. So a lot of my day-to-day work now is mostly in algorithm design and working with the physical robots, but I don't really have research in that area. My research mainly focuses on artificial intelligence, machine learning, and computer vision related applications for robotics.
Can you briefly describe what McGill's Mobile Robotics Lab does, and what do you do for them?
So McGill's Mobile Robotics Lab has a lot of wide range of projects that they have been working on, including marine robotics, aerial robotics, and ground robotics. When I was there during my PhD, a lot of the work was focused on coral reef monitoring and how the coral health has been changing over the years. And my specific area of interest was to see how we can use a fleet of robots from underwater to surface and try and make the two robots work together for autonomous survey of a given region where coral reefs are there. So from that point onwards, the lab has grown in different directions. There is a lot of interesting work which has been done in aerial robots, where you're sort of monitoring the seashores or coastal areas, and also in search and rescue sort of applications in marine environment as well as in aerial environments. So yeah, there's a whole range of work. They have looked into computer vision, which is sensing of the environment, then sort of planning as to how to distribute the work between different robots, and also the controls of it to sort of intelligently decide where to go next for surveying. So yeah, there are a wide range of exciting projects, and I hope to collaborate with them again. And yeah, we have some plans in for the upcoming year, and we'll see how that goes. Some of the fundamental challenges in ocean environment is the communication. So once the robot goes underwater, it cannot communicate, send signals up, because radio signals do not pass through water, so it cannot get GPS coordinates underwater. And it's very difficult to communicate with other robots around. Of course, we can use sonar sensors underwater, but it has its own disadvantage that you have to go set up these receivers before you send the robot in. So I think that's the biggest challenge, not having GPS and no communication. Because the robot cannot localize itself. It doesn't know where it is, and the wind and current which is there, so even if it's at the surface or underwater, it basically comes up, finds its location, goes down to a particular location, thinking that it's actually in the same column, but because of the current, it might have swayed away. So figuring out the right location of the robot is very tricky. That also means that you have to depend on features underwater to say that, like we depend on features like, okay, there was a McDonald's last time I came here, and then there was a Burger King next to it. So here we have to look for features underwater to place the robot clearly. And if there are no features, it's just a sandy seafloor, then it's very difficult for the robot to locate itself. If there are coral reefs, it's much easier because then it can find those features to guide itself. But most of the time, if it finds a feature, it doesn't know where it is found at. So that's the challenging part. And you have to mostly depend on vision for that purpose.